You ever notice two plastic things that are supposed to be the same color, but one of them is just a little bit off? You probably just figured it was a simple mistake, right? Well, today we're going to dive into the secret science of why getting plastic color right is one of the biggest, trickiest challenges in all of manufacturing.
Okay, let's just kick things off with a number that is, well, it's kind of hard to wrap your head around. In the world of color matching for plastics, there's a staggering 90% failure rate on the very first try. Yep, you heard that right. 9 times out of 10, the color comes out wrong. This isn't just some small oopsie. It's a huge, hidden cost that affects literally everything from our cars to our kitchen gadgets. And the science behind it is just fascinating.
So that massive failure rate, it all boils down to solving what sounds like a simple mystery. How is it possible that you can take the exact same red pigment, put it into 2 different kinds of plastic, and end up with 2 totally different shades of red? What is going on there?
Well, we've all been trained to think that color comes from the pigment, the dye or the paint. But that's where most people, and honestly a lot of manufacturers, get it completely wrong. The real secret isn't in what you add to the plastic, but in what you're adding it to.
Now this right here flips everything we think we know about color on its head. It turns out the pigment you so carefully choose, that's only about 30% of the story. The other 70%, the part that really decides the final color, comes from the plastic itself, the polymer, and the process used to make the thing.
So here's the crucial point. It's this simple but incredibly powerful formula. Every single type of plastic has its own natural built-in color, what the pros call its natural tone. And that hidden color mixes with the pigment's color to create the final shade you actually see. It's not a blank canvas at all. It's an active ingredient in the recipe.
And this quote just illustrates the problem perfectly. Think about it. If you paint blue onto a yellow piece of paper, you're going to get a greenish result, right? No matter how blue your paint is. The plastic base is acting just like that colored paper, filtering and changing the pigment's true color before you even see it. And this plays out in the real world every single day. You take a super common plastic like HDPE, it has this kind of yellowish natural tone to it. So you put a blue pigment in it, it's going to look a little bit green. Every time. But if you use polypropylene or PP, which has a more milky, slightly bluish tone, that same blue pigment comes out looking clean and crisp. Every plastic has its own secret color signature.
But wait, it gets even more complicated. It's not just the plastic's natural color we have to worry about. The second you actually start manufacturing the part, you introduce a whole new set of variables that can completely hijack the final shade.
See, as soon as those little plastic pellets get melted down so they can be molded into a shape, the whole game changes. That intense heat and pressure doesn't just shape the plastic, it fundamentally changes how the pigment itself behaves inside of it. If the processing temperature is just a little too high, you can literally cook the material. ABS plastic, which is already a little yellow, will start to get even more yellow. If you overheat nylon, it can start to look brownish. And those vibrant organic pigments, they can actually lose their strength and just fade out, leaving you with a dull, washed-out color.
And then there's this thing called the Melt Flow Index, or MFI. It's basically just a fancy way of saying how easily the melted plastic flows. Think of it like pouring water versus pouring honey. If you have a high MFI, the plastic flows easily, like water, spreading the pigment out nice and even for a bright, vibrant shade. But a low MFI, that's like trying to stir food coloring into honey. It's thick, it's slow, and you end up with clumps and a much darker, duller final color.
Now, some plastics are just special. They have these really specific quirks that make them even harder to work with. So let's take a closer look at one of them, nylon. It's a really popular, strong material, but its color is notoriously sensitive.
So after everything we've talked about, the natural tone, the heat, the flow rate, what's the one single thing you absolutely, positively have to control if you want to get the color of nylon right?
It's moisture, just plain old water. It's a factor we haven't even mentioned yet. You see, nylon is basically like a sponge. It just loves to suck water right out of the air. And even a tiny, tiny amount is enough to completely sabotage the color.
When that moist nylon gets processed, the water inside it turns to steam. And that steam just wreaks havoc on the pigment. It can make the final color look all grayish and faded. It can create this weird hazy white film on the surface, and it'll totally ruin that nice glossy finish. And this is why professionals have one ironclad rule. You always use pre-dried nylon. No exceptions.
Okay, wow. So we've seen all the ways this can go spectacularly wrong. You've got the polymer's secret color, the processing heat, the flow rate, even moisture in the air. So how in the world do the pros manage to get it right and produce millions of perfectly colored items every single day?
Well, they follow a super strict 5-step checklist. They control every single variable we've talked about. First, they analyze the polymer's natural tones so they know what they're starting with. Second, they use the exact same grade of plastic with a consistent MFI every single time. Third, they make sure the material is perfectly dry, especially for a material like nylon. Fourth, they lock in a precise processing temperature and don't deviate. And finally, get this, they even check the final color from multiple angles, because the way light hits an object can actually trick your eyes. It is a science of absolute precision.
So, the next time you see that tiny, almost invisible difference in color between two plastic parts, you'll know it isn't just a simple mistake. It's actually a story about polymer science, thermodynamics, and fluid dynamics. It's a testament to this hidden world of complexity that shapes the everyday objects all around us. It really proves that even in something as simple as color, there are incredible depths we rarely ever get to see.
Let me end with something important. A technician matched the same color Masterbatch in the HDPE, PP, ABS and Nylon. Some pigment, some dose, some machine setting. But the result? HDPE looked dull, PP looked clean, ABS looked rich and Nylon looked washed out. The mistake wasn't in the color. It was ignoring the polymer base, natural tone, MFI flow and moisture content quickly change how color develops during processing. And once you understand this, you stop asking why is the shade wrong. You start asking the right question: is the polymer behaving differently? That's when color matching becomes engineering, not trial and error. See you in the next video.